can we astrophotographers photograph something that took NASA a space telescope to discover? Well, stick with me and let's find out. So as many of you may know, a supernova is a massive star that collapses upon itself and explodes. Now this is a spectacular view, and something happened roughly 5,000 to 30,000 years ago, visible from our skies. Now this exploding star will reach peak brightness after a few weeks, only to decline in brightness, which can take a few years or so. And the remnant of this star will either be a white dwarf, a neutron star, or a pulsar, or a black hole. That depends on the initial mass of the star that actually exploded. Now this happened a very long time ago, but what we can see is the spectacular remnant from these explosions, the supernova remnant. And it's just right in the sky for me, so I'm going to take a photograph of that and also see if I actually can capture the remnant, the neutron star or the pulsar that we now know exists. But it took NASA a space telescope, a Chandra space telescope to be precise, to actually discover whereabouts this neutron star is. So the fun part here is that this remnant, called the Jellyfish nebula, is just perfect from my balcony. I can easily get 3 or 4 or maybe even 5 hours of data per night. So my plan is to spend as much time as possible on this target using the 3 narrowband filters that I have: hydrogen, sulfur and oxygen. And for those wondering what that is, I have a video describing just that, and I'm just gonna link it somewhere up here. So I expect to have a spectacular image of the remnant, and also I'm very curious to see, can I see the pulsar in my final image? So although winter is coming in Sweden and we got like 20 hours of darkness per day, it's still extremely cloudy here, sometimes for like weeks in a row. But the following days, however, it's forecasted to have some clear nights. So I'm hoping to kick off this project taking H-alpha data, and hopefully I'll get enough and can continue to the sulfur 2 and the oxygen 3 filters later on. So yeah, let's just rig up for this time and see what the results give me. So as I already mentioned, it turns out that the star that exploded is now a rapidly spinning pulsar, and astronomically this was just recently discovered. It was discovered at 2015 by NASA using the Chandra Space Telescope, and we now know exactly what it is. So the question is, can I, or we as astrophotographers, locate this remnant and actually photograph it from our own telescopes here on Earth? Alright, so it has been roughly 3 weeks since I started this project now, and I have collected about 10-11 hours of hydrogen alpha data. So we can finally have a look if there is any pulsar visible in the photographs at this early stage of the photographs. So I have prepared everything in my computer. I have stacked the image. I haven't stretched it yet, so we're going to do this together. And I am super excited to see what will turn up. So let's go to the computer and see if we can find anything. So what we have here is an image from NASA looking at the Chandra Space Telescope and exactly where the supernova remnant is. And to be honest, I was a little bit surprised when I saw these results initially, because I thought that the pulsar, the remnant, should be somewhere in the center of this huge explosion, but it appears to be somewhere down here, if up is up in this image. So this is this box here. This is the detailed image from the X-ray and optical data. And if we zoom in here, we can see that the supernova, or the pulsar that we are looking for, is this one. Whoa. It's this one here. So what I'm gonna have to do here is that I'm gonna have to star jump, I guess, and I think I'm gonna use this, and then probably these three, creating a triangle. So yeah, let's go ahead and stretch the hydrogen alpha data that I prepared here and see what we get. So this is not going to be a stretch for the books. I'm just trying to stretch it a little bit. I'm more looking for the pulsar and not the results of the hydrogen alpha here. So I will probably push it a little bit harder than I need to, but this is just to have a look at an exciting pulsar. Let's see, here we can see the remnant coming up, and it is looking good. There we are. Look at that. Oh, nice. Let me just go a little bit. Oh, there we are. Oh, and this is an area that I really like. And here we can see the kind of jet-like stream that comes out. And if we are looking at the NASA image, it's probably somewhere here that we're gonna need to be looking. So let me just push this image data a little further. Yeah, look at that. There's something there as well. Nice. And a little bit of haloing there on the bright star. Okay, so now I push this image way too much. This is not necessary for the final image, but this is, as I mentioned, only to find the remnant. So let's have a look here. We are in this area here, and that would correspond to somewhere around this area here. So now I have to find stars to star jump a little bit, because we have these we got 1, 2, 3 major stars down here, and these are basically pointing, these two are pointing in the direction of where we want to be. So let's have a look at here. It's these three, and these two are pointing roughly in the direction that we want to be. So it's somewhere here then. Then we have 3 additional stars there. Let's see if we can find them. There they are. So these are also pointing into the direction of these 3 stars that I want to jump to. So this one is pointing to the stars that I want. So I think it's this area here. Let's see, 1, 2, 3, 4, 5. 1. Oh, I have 1, 2, 3, 4, 5, and then the triangle. I think I'm in the right place here. 1, 2, 3, 4, yeah, and then the triangle. Yeah, exactly. So this is the area here, and that corresponds to the area here. So let's have a look. So yeah, that is a bit disappointing. Looking at the image that we need to be looking at. We have the triangle here, 1, 2, 3 stars, and then in the middle, or at the base of the line between this and this star, then we should have a pulsar roughly at the height of the third star. So the pulsar needs to be somewhere around here, because this is the line and at the height of this star over here. So yeah, that was a little bit disappointing. But I am not discouraged yet. We still have oxygen 3 and sulfur 2 to take. So this is basically just a third of the data. This is just the initial results. I couldn't help myself. I had to see if I could see the pulsar or not from my images. But well, let's continue taking some more photographs and see if we can get this pulsar on image, shall we? Oh, and by the way, if you're enjoying this video, do give it a like. It helps a lot. Also, feel free to write any suggestions or thoughts in the comment section. They are highly welcome. And if you want to see more of me, of course, don't forget to subscribe. It has now been almost 3 months since the last scene that I took, and I have finally managed to collect enough data to create the proper SHO image, and I am very curious to see if I actually got the pulsar on the photographs. So I have the computer here, and I was thinking that we will do this together again, and hopefully there's something to be seen here. And what I have done here is that I have prepared the data a little bit because it's a bit tedious. I have the original data here, the SHO data here in this group here, and it's simply stretched. And then what I did is that I took the S and the H layer and I put them into screen blending mode. And this is just to add up the data because I'm not sure that if I just put them on different channels like a proper HSO image, it's not going to work for what I want right now. If we look at it, because I want all of the data to be added together, because this is a very faint object and I'm not sure even, well, let's see if it's in the image. So again, we have these 3 here that create the triangle that will point in the direction of where we need to go, which is somewhere around here. And let's see here. Yeah, it's here. So here we have 1, 2, 3, and then we have this triangle, and look at that. Between these 2 stars, on the height of this star, there should be something there, and I don't know if you can see it, but there is something really, really faint there. See, I don't know if I'm just a bit optimistic here, but that one is, let's have a look. That's the H alpha, and that is the NASA image. And this, see, just between this and this star, I don't have a resolution to actually separate these 3 stars. But between these and this star, at basically at the height of this, there is this ring here with the pulsar. And yeah, I think there's something there. Let me see if I can adjust this a little bit more. First of all, if I invert, well, not that one. If I invert the entire, yeah, now you can see it. There is something there. And I want to believe that this is the pulsar. And that is so cool. So this one here, let me just paint it black. That little spot there was the one creating this supernova remnant. Over there. This is so cool. Yeah, well, there you go. Oh yeah, this is so cool. I think that is the pulsar. I could be completely wrong, but I don't think so. This is so cool. So it looks like we can capture the pulsar using a simple, well, using the ground-based telescopes. But I don't know, what do you guys think? Did I catch that pulsar or not? Anyways, I do have one more thing to show you, and that is the complete HSO image, and I'm just gonna put it at the end of this video. But if you like this video, don't forget to give it a like, it helps a lot. And if you have any thoughts or comments, do write them down in the comment section. And as usual, if you want to see more of my content and the things that I do from a Bortle 9 balcony, don't forget to subscribe. And yeah, I guess I'll see you next time. Enjoy this image of the Jellyfish Nebula in HSO from Bortle 9, and see you next time. And see you next time.